So in this problem, we have to find the median of two sorted arrays. So because they are sorted arrays, we can choose any one of them to figure out the median by using a binary search. And there are a couple of properties that the binary search will use. If we didn't have them as sorted, we would have used essentially merge function to merge the arrays, sort them, and then find the middle value. Because they are sorted, we can go ahead and apply a more efficient algorithm. So in this case, as you can see, we start first of all we find out which of the two arrays are smaller in length, because um, that's the one that you would prefer to do binary search on. Find out the length of the two arrays x and y, set your low and high to 0 and x respectively, and if x and y both are 0, that essentially means that both of them are empty. Then in that case there is no median, so that's the special case, just return 0. If x is 0, in that case you're trying to figure out whether um, you've reached the beginning essentially, and so check if y mod 2 is equals to 0, and in that case you will return this um, as your median. Otherwise you'll return nums of 2, because there is nothing on the x side, so all of the computation will be on the y side for returning your median. If in case it's an even number of even set of numbers, then you essentially do this. And the reason why x can be 0, this is again a special case where your smaller array could be empty, your larger array could be non-empty. And so if it's not empty and it's even, then you have to find out the middle value. So if it has 6 numbers, then the third and the fourth, whatever the third and the fourth, the average of the two. If it's odd number of elements in the larger array, then just then in that case you just do by 2. So these are the two special cases to handle. After that, you just go ahead and find out whether low is less than or equal to high. So that is the typical binary search condition. Partition x, you start with the midpoint of low and high by 2, and partition y automatically will become x plus y plus 1 by 2 minus partition x, because the median of two sorted arrays will be in the middle, and we have x plus y plus 1 by 2 elements on the left, and x plus y plus 1 by 2 elements on the right. And the reason why we do the plus 1 is to handle the even odd case. And so if you have decided your partition x to be the mid value between low and high, you can automatically derive the partition y using this property that you have to have equal number of elements on the left side and on the right side. Once you have that, then you don't have to care about any other elements in either of those arrays but these 4 elements. The first element is essentially the max left x, so whichever is the maximum value left of the partition x, so that's the max left x. Max left y is just the preceding element of partition y. Similarly, min right x and min right y, which are essentially partition x and partition y. And so you get these 4 numbers and you check if max left x is less than equal to min right y and max left y is less than equal to min right x. When this happens, then you have equal number of elements on the left side and on the right side, plus you have the condition satisfied for it being the median. So you've arrived at the median value, and so now you can kind of compute the median using these 4 numbers and handle the odd and the even case. If in case this condition is not met, then either you're too much on the left or too much on the right. So if in case you're too much on the if your max left x is greater than min right y, then that means that you have to come a little bit on the left, so reduce your high to partition x minus 1. But if in case your max left x is less than min right y, then you have to go a little bit on the right, so increase your low to partition x plus 1. And then this keeps on going till the time binary search finds the right place where you find the median and return it. So So yeah, so you're exploiting like two properties here. One is that property of deriving partition y from partition x, and the other one is using four numbers which are right at the middle to find out whether this particular condition is satisfied or not. So that's kind of like those two properties. This is the property for finding out your median, and this is the property of having equal number of elements on both sides. So if you get these two properties, you can use binary search and you can do this problem in big O of log n time, which is great. Thank you. Bye.